Sorry, Zoom's like kind of fighting me on some stuff, but we have a nice little recording coming up here. We'll be all right. Fun times. Bio 444 Pathophys, but again, even though it's actually an official class, technically we have to lead us to 490. These, oh, Monica, you could like put these away. So we got here, these little guys right here are credit displacers. So you can take these, we'll fill them out together. We'll take like one of the breaks. I'll actually pull up the little camera thingy there, and I'll show you what to fill in. It'll basically say these 3 credits of 490 should count towards whatever you want them to. So if you're a biomed major, put it in your major electives. If you're a biochem, you would say, I'm going to put this in my bio upper electives, whatever works best for you. And we'll work on these today. We should finish early. I don't know though. We'll see. I like to talk, so we'll figure out what happens. All right, so hooray! Most of you have had me. Literally, actually, wait a second. Almost everybody has had me in the class. So good times. I've gotten more evil, more crazy, all the bad things. Don't worry. But at the end of the day, love what I do. Those are the goals up there. Why I do whatever I do. It is to foster success for you. The best classes will always be just above where you're at right now in week 1 and in week 16. You're a lot bigger and stronger and cooler. Okay. Now to get there, that balances that point right there. People are stealing your money if you take a class and it's just nothing. It doesn't do anything. Okay. Now on the other end, I can't just like destroy you and be like, it's really rude. And that's because it's not going to learn anything. The other side of this too. If I want to challenge, I have to offer the support, which we do. Utilize the office hours and the open hours, all that fun stuff. It's an easy resource. I really do like what I do. I want to actually teach, so it's a big deal. Hopefully with this class too, this is going to offer us some interesting sides of stuff. Most of you mainly have me from genetics. That's a big 90-person class. This, we have some more options. Case study type stuff, fun problem solving. Who's ever seen the show House, where you figure out what the thing is? Oh yeah, we're gonna do some stuff. I have an AI assistant now that's gonna do us a little text game. I've trained it to basically do like a back and forth to diagnose stuff. We'll have some fun. So regardless, the cool part, and I always put this little note for whatever class I'm in. Sorry if you guys are having me twice this year, Ava and Zach. It's all right. I actually never got to take a pathophys. It was off rotation at Carleton when I was a college student there. But it was actually, I took it sort of in high school. And it was the first time that I was like, this is awesome. There's so many bad things. There's so many cool things. In the same way, the cool part of this being the first time I've taught this course, that enthusiasm's big there, just like in cancer bio though, or like those of you who had me in genetics when it was like kind of first around, there will be times where I'm like, this red text slide is a little heavy duty. Maybe this is more blue. I'll note that in my class. We'll be fine. But this is always the goal. Hooray, hooray. Fun. It's not possible to reach that goal every time, but that's the aim. That said, too, the other aim is to get everybody across the finish line. At your goal, I will also fail that. This is the way the chips fall sometimes. We'll see what happens. Because no matter what, at the end of the day, and those of you who probably explored the little pathodex, right? There's a lot of diseases out there. A lot of stuff's trying to kill you. At the end of the day, you gotta know it. Pass the class. Confident we can. And like you've seen me in class before, I don't take the tests. You do. You got to sink the shots. I can set you up to beat the best, but you got to be the one to do it. Okay. Oh, I love this. You know, this is good now because this actually happened last term a little bit. So here's me in a personality test. I am sad. That's okay. This is why you shouldn't take this class. I always start with this. Kind of a little like business thing. All right. Oh, last term. Oh, we did this. A couple people were like, you got me like 6 points laying around for that genetics class, maybe? I was just like, no, I didn't take that well. Let's just say, hey, you meet the outcomes or you don't. If you were playing soccer or some other thing, and it's like, how many goals do you score versus the other team? And if it was like less than that, there's no chance, man. Come on. Data's data. I'm a cancer data person. So at the end of the day, you can't handle the challenge and support that we've got in this class. That's the key thing. I will say, Ava and Zach and Farm, I think I might have scared everybody with this next line, but be honest right now, as enthusiastic as I am for this is a serious thing. I got no patience for unaccountability, crazy shit. I'm not a social worker, okay? So if you guys can't handle your shit, I'm going to refer you to somebody that can, okay? Because I'm tired of dealing with other people's crap at this point. Oh man, sorry. Anyway, who's ever seen this movie? Yeah, there we go. Nice little line. Ween. All right. Anyway, some more fun stuff about me to get to know me a little bit. This is, I think, a Gallup poll survey. It's fun. There's like 40 of those little thingies. Yeah. Cool thing with this, and with pathophys is the sort of foil to this. Every weakness is a strength in its own way, and every strength is a weakness in its own way. Yes, I love learning. Hooray. I like reading and doing other stuff. That means I don't spend as much time doing things and finishing things, right? Things like that. Now, number 2 and number 4 oddly are in a bit of a fight against one another, but what the thing said was like, you want things to be harmonious, so you just settle everybody down a lot. I don't know. I think it's fine. We had a good time. Genetics was under control, right? We're fine. We had a good time. Other than that, that's kind of who you're dealing with, hopefully. All right. Most of you guys know the drill, but for the common answer, what is on the exam? Enough right here. Now, unique thing with this and farm is that I gave you something unique, different here. That Excel sheet, the little pathodex, that is also theoretically red text, right? Now, when you're off time, you can build that thing up pretty quick. You can even have the AI assistant help you if you trust it enough. I don't mind. But as long as you can build it on your own, you'll build that red. Now, the red that we'll see in a lot of cases, I will go through specific examples. I will not go through every single disease on that list. Similar to if you take anatomy, we can't go through every literal thing. We can go through the big ones. But we'll hit the big examples here that I think will set us up for the most success. All right, green, these are fun story times. We're going to see all kinds of death and terrible, crazy, scary stuff, right? Just relax. We're going to do some stories and some history once in a while. It's a good time. It's a good break. Blue is the weird one. There will be slides that are so dense that I'll say blue. And what I want you to know from blue slides is that take what you need from this to help you contextualize all the red stuff. That's the main thing. Blue is the weirdest one. If you have a question on a blue, throw it up. Like we did it even in a 90-person genetics class. We typically had time to answer some questions. We definitely have that time in here. So definitely trust me on that one. Also, my favorite, if you're colorblind, please let me know. I have people go through the entire class not knowing. Don't be that person, please. Just email me. So, all this terrible stuff, what's the reward? Like I said, an education is something people 200, 150 years ago had to fight for. You guys are in the room right now. It's cool and badass. You get to become stronger, more powerful, and know the world better. And man, along the way, you get to see some crazy bad stuff. And we're going to do all this bad shit. Oh, God. Sorry, there's going to be times where I'm like, you might want to look away. But we'll see what happens. All right. For you guys that have had me see my favorite little thing on there, where is it? It's my favorite part. What's my favorite thing on here? Oh. Leptin mouse. Oh, it's hungry too. It's angry. All right. So, good times. Like I said, patho was the first time I was like, dang, I kind of want to maybe do some medicine, something. Maybe. We'll see the ways that we can get through this too. So 25 points should automatically be loaded in for you. Either these are yours to lose. Most of you are pre-health, pre-something. All these is saying, are you participating in class? Are you accountable? Et cetera, et cetera. Are you on time? Are you doing the basics? That's the main thing, okay? Key thing that a lot of employers complain about is like, literally, we have college graduates that just literally don't say anything, they don't do anything, and like, we don't do that here. There's only 15 of us, we get to know each other by the end. It's like when you take a trip, like in like some other country, and you become best friends after a while, right? United in your hatred of the content and the professor, right? Oh, it's fine, don't worry. Regardless, these basics are here to prevent things like that. Now, if you do end up in real healthcare and something like surgery, yeah, you're going to kill someone eventually. That's the facts of life. The more of those small things that we can do, the basics, the more we can figure this out. So, regardless, biggest thing for me, communicate, okay? If you're going to be late, you're going to be missing, I don't care, just figure it out. Send me some plans, organize the way. The type A people were right in most cases, okay? All right, so kind of introduce myself a bit, even though, again, I think there's about 15 of you in here that have already seen this, but too bad, you get to do it again. All right. So, born in Colorado, hooray, hooray. I'm right close to that cool little Instagram place called Hanging Lake. You should Google it. It's very cool. We were naughty as children when there was no tourists, and we would jump off that tree. Very bad. Anyway, bad little children. Next, ended up in Minnesota somehow. Went down to the little cornfield east over here and went to Carleton. It was very fun. Everybody was a huge nerd, and I'm still paying the student loan debt, so whoops. You're a lot smarter than me to be in this room and have a nice state school price. Next, Omaha. Super underrated. Loved Omaha. Went to the Warren Buffett Cancer Center, did my PhD, had an awesome time. Saw some cows too. Next, ended up at Mayo Clinic in Rochester, was a scientist for a while. We had a great time. Me and Dr. Ann Novak's team. Now we're here. Because I did want to teach more than I wanted to research. But the cool part about MSU is that I can still do the cancer research and the data side that I use, but focus is teaching here. That's always going to be what I wanted, especially from the reason I wanted to teach was I had profs here that I was like, I don't know really what I want to do, but I want to do what that guy does. That's that. So that's me. So for you guys, just go ahead and see around how everybody's doing, introduce a bit, what you're up to, things like that.
I'm Lucy from Spamtown, USA, Minnesota. If you guys are into that, so that's boring. Oh, my director is so yeah. It's not chill.
You know, I wanted
and then Julia retired.
Whatever you think's gonna make me laugh, Ashton.
Are you really?
But some of you guys just kind of set it up as saying we're secret.
That's not entering on here.
No, I can't.
That's not entering on here.
No, don't, not yet. Wait, don't do anything with the card yet. I was just passing them out.
Yeah, honestly, I was like, good school.
Yeah.
Make sure you're
Yes.
I'm like, if I'm gonna go out of grad school, once I want to go for it. Still stay school, but she's undergrad.
We just.
Fair enough. Fair enough.
You know, it's
Not yet,
just,
no.
yeah, like, you know, I.
All right. Play a little game here too, since I've had so many of you in class before. You've seen this slide where I rank myself and how evil I am in each class. What would you move on here? Phys Labs is the easiest. I'm just a joke. We're just there to have fun. Like, I am not running the class. It's easy. So there's me as SpongeBob up there. I don't know. What do you think? You guys have that? Well, what do you have to do bioinformatics? Yeah. Is genetics down here? Come on, it's not that bad. All right, cancer bio, Zach, you said keep it there, right? Ashton, what would you say?
I don't know. I'd put it up one.
Okay, yeah, Ashton's vote is right there. Good. Okay, so what else we got? We'll see what happens with the other ones, I suppose. We'll see. All right, there you go. Now you got someone to fill in that intro card. The last one, though, number 9. As you go through today, keep it on the back. If you generate questions that you have about the class in any way, that's where you can kind of keep them because you'll hand these in to me at the end. We'll do our best on the, and again, you can kind of, these are kind of informal, so don't worry, but I do try to get to know everybody and see what we have in common. I'm a bit of a jack of all trades type of guy. I kind of like a lot of things, so chances are I'll know something, and that's fun. Good times. So, in the meantime, I can yell at you for what I expect from you. Given that this is a 400 level biology class, well, it's sort of prep for that post-healthcare med school type of expectation. That said, we're not a med center. You don't need to study 8 to 9 hours a week per class. The expectation is a bit lower in undergrad. But technically, you know where the 3 credits for a lecture technically come from? 1 credit in means 2 to 3 out studying. That's the old school idea of where those numbers come from. Now again, maybe you don't need that. But if the first few quizzes or problem sets or exams don't go super well, that's probably my first guy that we're going to do right there. Now, easy stuff is, yeah, you're here. We don't really technically have, we don't have strict review sessions. Sorry, that was more of a genetics thing. But basics, like even if things are going easy, if you check into the office or open hours once in a while, it's easy enough to just check in, see how class is going. I mean, if you like demolish this class and it's great, come to the office hours and just like talk about cool stuff. Like that's what those are for too. So cool stuff. Now, if you want to start fostering more advanced approaches, and I don't know if, you may not need to in a lot of cases, I'm here to also, I read a lot of like all the ed stuff, like I take classes on how to teach, all that cognitive stuff. I can teach you how to do these weird things, the retrieval practice, the 3-3-1s, the Feynmans, all that, okay? That can take you pretty far on stuff. The other key thing in detail with this class, and farm to a different degree, is that with the list and what we need to know of all the conditions, it's a different approach than genetics, which most of you had me in, which is puzzles, solving concepts. This is more straightforward. I'm not going to lie. There are certain answers to things that are just, that's that. Now, given that, we'll still have a lot of like short answer, longer answer type stuff with like data information, case study type stuff. But don't be intimidated by those style of questions. I actually see people do pretty well on those overall most of the time. A little more forgiving than you think. Oh no, time to yell at you too. Angry. Again, some of these are more for genetics, like piss off your lab partners. Not an ideal scenario. But again, the main things are these little percentages down here. Even though I have some very strict outcomes in this class, I am going to still do the note page for each thing. You have a whole sheet of paper that you can fill in whatever you want. I don't care. We'll see how it goes. I think it'll still work. But the key way to really screw things up is you just don't use the resources that you have. And I'm telling you about any class that you've got out there, not just this one. And then my big, fun, crazy research question right here. It's kind of a psych one. This was from a research presentation in Michigan. What do you think that answer is right there on the bottom? And again, you guys have gone through classes with me. You know what we're going to talk about here. It's not 100%. To learn something is not all on you. I have to do something. Not 0% because I can't just hammer stuff into your brain, right? Where does that number fall for you? You don't need to shout it out, just think. And think how it's changed over college too. It's also a good self-reflection time. What the Michigan group found was that anybody that said over 70 was in a higher tier. They took more responsibility, put more on themselves to push. Anybody that went below 40 was in a different tier, and they struggled in the class. That class specifically that they studied was actually genetics of all things. So consider, you are not alone in this. I am here to guide you through this. But like we saw in the beginning, you got to win the game. Okay, strong study plan. All right, so the good news for you guys is I think Mondays, Tuesdays, we do have an open hour before this class, right? I have office hours before this and the evening stuff. Good. You can always kind of review before class on Tuesdays. I have a bunch. I think I'll have office hours, I think a little tomorrow, a bunch of stuff on Friday too. And I know everybody hates coming into school on Friday, but then there's more attention and we can figure stuff out. The good news with the open hour too is you will see each other in it and we'll start to build like sort of a common, like, let's figure this out. I don't care how you build the pathodex and fill it in. You can work together. I don't mind that. Like, that's perfect. As long as you feel as though you're still understanding it, perfect, okay? So build up this organization stuff. Like I said, the type A people, they were right. If you go back to that personality test I did, and I've told you guys this before, I am right in the middle of a type A and a type B person, and it's just pain. Because every time I want to do something else, like, let's just wing it. And then I realize, anyway, so Who else has ever had like a 3-hour class like this? Yeah, technically you've all been in labs. So, but I'm gonna promise you, I'm gonna do my best to get away from this. We're not gonna do this all the time. I'm gonna try and we're gonna have open times where we can talk about stuff, think about stuff, kind of enjoy. I can potentially line up some activities in the lab like we did for cancer bio. We'll think about it, but I gotta get my hands on some more rats maybe. We'll see. They're dead already. Don't worry, I'm gonna kill them. Anyway, yeah, sorry, that was an inside cancer biology joke. All right, so good news is hopefully we don't get demolished by lecture. Problem, and I'll admit this is a weakness of mine. Whenever I first design a class, I put a lot of slides on and I sort of tapered down after that. We'll do our best. Again, a lot of us haven't actually had true phys class quite yet, so I do want to make sure everybody has that background as we go. But I think we have a good minimalist approach. And what I'll do sometimes with the key info is turn a lot of red text into blue and kind of relax everything, hopefully. All right. You don't have to share anything, but I also like starting this out with classes and kind of think to yourselves, what are pieces that you as a learner and me as a teacher, professor can sort of good things? And then more, I don't know, more broadly, memorable, meaningful, what are those? In the meantime, I'm going to pass you out something else. You guys are in the big leagues now. Look at these little cards. You guys remember the cards or what? My other classes. Here, pass the A to Ashton. He gets the ace. All right. So go ahead and put your name on these and like something like 1 or 2 or 3 things that are like identifying or fun about you so that I'll know. All right, I got some fun Sharpies up here too because these are waterproof-ish, but you guys are in the big leagues now, like I said, these are fancy cards. 1, 2. Some of you might actually have. Yeah, yeah, you just pass the Sharpies around too.
1, 2, or 3.
3. 2.
That's the one I wanted.
Yes.
Neither did I. I was wrong.
Okay. All right, Sharpie, you guys got.
I don't have.
Oh, your name and just a couple things about you. Yes. Orange.
Yeah.
Black.
It's the best color. It's the best.
Oh, you need a card.
Yeah.
4.
Yeah.
1 card. Okay.
So don't put me.
Yeah, wait, I
Only
forgot.
use it
what
to
I-
make fun of
You're
you.
right. This is, all right.
Something that like.
Yeah, so name and so on the cards. Yeah, wait, let's blank this out because otherwise people write that. All right, sorry. I was just getting you thinking about stuff. So on the card, just name and like 1, 2 fun / unique things about you. Like what do you do? Just anything that's fun. I'll use it as sort of an identifier as I get to know everybody. What did we have in farm? It was funny, like 3 people put caffeine addict, and I was like, that's close to home in this class. Okay. Addict, drug, okay. There we go. Good. Stop.
I'm listening. Hey, New Year's resolution. Hey, lay back the energy drink.
The way that this is structured, this class, this first 5 weeks leading up to that first exam, we're going to see a few things that are fairly familiar. We're going to see the broadest possible systems. Today, we're going to meet all the cells, all the sort of kind of chemical and small injuries that we can potentially have. This actually is going to focus mostly on just straight up aging. Second week, we're going to do some immunology. No, wait, second week, I think we do, second week we do the immunology stuff because that's every system. The next, we get to do the infectious bad guys. It's always a fun one. One after that, I believe, we get into the brain. No, we do the genetic diseases. That's right. So, first third of the class, this first phase, will feel familiar, hopefully. That's the idea. There will be sometimes a lot of red text on stuff. I will do my best to highlight what I want you to know from these pieces. That is the style that we're working with here. Again, the reason I do the recordings and the slides is that I know it's a lot and I acknowledge that. Good students use those pieces. That's who I'm teaching. Okay, let's roll. Cells depend on genes, all that good stuff, right? A lot of these conditions that we'll see throughout this class depends on single cells dying and misaligning. Now, this is included in here. Like I said, you will begin without trying. You will start to learn Latin, surprisingly. It's a strange feeling when you take this class. You start to see the same ideas, definitions, and the same like synonyms and prefixes, things like that, okay? These key parts right here, I would say, etiology is one of our more important ones. What is the cause of a disease? That's a red texter right there, because that's what's in the pathodex as. That's a fancy sounding word, but what causes this thing to happen? Some etiologies are tough. Bipolar syndrome, for example. Some etiologies of conditions are really easy. What's the etiology of a gunshot wound? Kind of in the name, huh? Yeah. Some are easier versus harder. Chronic versus acute. Not a bad one to know. Acute means sudden onset, bad things. Chronic means long-term, festering, over time. I'd like to see here. One of our favorite ones, like we talked about, House MD, idiopathic. No idea what it is. No known cause. Shoot. Coming to mind on that, still probably make the case that a lot of Alzheimer's and a lot of Parkinson's cases are no known cause. Plenty of still pieces of that. But we have big associations, to say the least. Now, pathogenesis itself and pathology sort of squish into the same idea for us on mechanisms, I'd say. So the only reason we're spending this much time on a blue text slide is these are some definitions that you'll see on that pathodex that does have the definitions on there for you, but it doesn't hurt. So to use a blue text slide, if you want to study it more, it will unlock more associations for you. It will make the red text easier. If you have to focus on one thing, obviously start red. Okay, there we go. The only reason this thing's in red is because y'all know that from 105, right? Look at that big boy. There's all kinds of stuff in there. You knock any of those parts out, different bad things that are going to happen, okay? We're going to focus on the main stuff. I'm not going to lie to you. Give me that red back. See those little nasty little mitochondria? I would say about 70% of all the cell injuries we're going to see. Them going bad, it's them aging. Nasty little guys, you can make fun of them all you want, and they can annoy you all they want with the Krebs cycle, but it's the mitochondria that are going to cause a lot of this bad stuff. But inside the cell holds the other system. That's why genetics is one of the prereqs for this class. There's a lot of diseases out there that you may have a couple defective, recessive, bad genes. One from mom, one from dad, just like the old days. You got two bad copies, it's not going to be good. It's not going to produce the right stuff. Not ideal. Y'all know that. Okay. Yeah. Not ideal, right? You get older. Mitochondria are one of the bigger things that will lead to aging strictly. But we're going to see all the neat stuff that's happened in the last few years. I spoke about Alzheimer's and Parkinson's, some of those other brain things. It's where we're finding all the sources are caused from these. What organ uses the most energy proportional to its size? Why are you tired during exam week? Your brain. It's moving, it's burning all the time. It's burning all that energy to move all this stuff. As it gets slower, as you age, it goes down. We will also see some more direct ways you can injure brain cells, obviously concussions, things like that. If you injure the cells themselves and these get damaged, it's not a good deal. They're going to leak all their stuff and they're going to kill you slowly or quickly. So, a lot of factors, but at the end of the day, this slide is here to showcase and make sure you know a lot of the genesis of this stuff is coming from these guys. So it doesn't hurt to know what they're up to. Now, fun time for cool stuff. Mitochondrial transplant. Your mitochondria came to you from your mother. Female mammal egg holds all the mitochondria. Male sperm does not. We're working on things that when these have a disease, you transplant these into your cells effectively and de-age somebody. Working in the mice. It's incredible. Yeah, and like, what's that? That's a very popular Twitter crazy right now. De-aging and taking all the pills and doing all the weird stuff. let's just say we're gonna get to tumors later. Don't dysregulate your body, please. Don't take testosterone or other weird stuff that Shannon Sharp sells you, okay? All right, cells. Here's a key thing for cells. You got trillions of them, but it's the language that they speak. And when you take their words away, when you remove their ability to communicate or work properly, that's when you get, like I said, our favorite Latin prefix will be this, dysfunction. All these dysfunctions, most of them come from when things are working fine. All the stuff you've seen in 105, all the enzymes, surface receptors, all that. If they go down, the genesis of disease. Strictly speaking, too, cells have another need and capability. I'm not gonna lie, I would maybe put this as blue text, but I wanted to include it because it does help you recognize that the systems in your body, your cells don't know gravity the way we do. They have to be told which way to point, which way to absorb things. For example, your intestine and your lumen, you want to absorb all that glucose. The way your intestine's designed, it's a one-way street this way. Take it all. Now again, this is a bigger, broader day, and I know it's only Tuesday of week 1, but hey, it's a fun 400 level. You screw up transport, you'll die. Screw up enzymes, bad. Screw up any cell surface receptors of any kind. Dysregulation. Things are not happy. This can start from a single cell. Things go wrong. We'll meet the tumor basics today as well. Keep them in mind. We'll also see everything that you've seen or can see in physiology when it goes wrong. It starts here. Okay. Next. These slides focus on communication as signals. What you saw in the last slide was single cells and their functions. Notice up here, though, look at all the ways that cells can talk to each other, tell each other what to do. First one's easy. One has a signal on top of it, the other has another signal, they meet. Tell each other what to do. Easy enough. Plenty of your genetic diseases are that you are simply missing this gene right here, that receptor. Receptors are genes. You could be double recessive for it. No receptor there, no communication. Whatever's going to happen is going to happen now. So, next, multiple other ways to communicate, one of which is strange. Plenty of cells spit out signals that make them do their thing. Autoprint, or Latin, auto means self, self signal. Para, neighbor, neighbor signal. Multiple ways for the system to go down, right? You could lose the signal itself. You could lose any of the receptors that feed the signal. You lose that, or you lose that. There you go. Two-way street. Either way, if you can't send the signal or you can't receive it, it's a blank slate. Okay, get a little bigger here. Endocrine system and your brain cells, they work special. People sleep on the endocrine and the hormone stuff. Who remembers that you were supposed to turn in the quiz today? Yeah, did you feel that? Wasn't happy, was it? You got a little stick, you got a little cortisol, and it was like, see that? How's that feeling right there? That is a stronger move on your body. The brain is a quick reaction. But if we deregulate these, the body can't function the same way. Those big move signals across the blood, it's not a good time. Speaking of other conditions, we'll get to the heart and the blood. If that doesn't function, then that one goes down, right? No more flow, no more highway. Clots, strokes, fibrosis, all of it. Okay. Oh, these are just repeats of the same thing, but they're nicer. Sorry. The last one. Theoretically, this is just paracrine, right? One signal given to the other. You can have neuron on neuron, you can have neuron on cell. But You lose this connection, now we're in trouble. What kind of connections, neuron to neuron, are you losing? What kind of diseases does that sound like? Brain starts fading away. Was that the ideas? Alzheimer's, Parkinson's, yeah. Just straight up dementia too. Nerve cell to muscle cell. What condition is that? As slowly but surely you stop being able to move. ALS, yeah. That's what our first dog had. But he was 11 and what happens. But it's a slow, bad thing to see. You lose these signals, guys. Different setup. It's a different utility belt that you're gonna lose. Different ways. Okay. In blue though. What I mean by fate is that when this is kind of the basic setup, and you will see this model throughout the class. Number one, incoming signals. Little things that we've been talking about. A ligand is a fancy way to say that, but for our purposes, it's fine to say just signal. Needs to be received by a receptor, like we talked about. What the receptor will physically do is say, make me more signal down here. I want to trigger something to happen. One of those ways is to. Some of those consequences are down here. Plenty of cell signals are the basics, the mitosis, the stuff why you have genetics as prereq for this class. Plenty of signals say, do mitosis. Plenty of signals say, do apoptosis and blow the cell up and die. That's this little guy right here. Plenty of them say differentiate, this one right here. Not all your cells are the same, right? You have intestine cells, you got heart cells, you got brain cells, right? At one point, they were told, you become this. And again, it's a good example of blue text slide, where there's a lot of things going on. It's a nice, rich, fun example, but it's the system for you to watch through. When signals bind, things happen. When they bind certain types of enzymes, certain things happen. So, notice on a couple of these. This little guy right here is what we call a channel. When it binds, it lets sodium, potassium, things like that through. You guys did sodium, potassium pump in 105, right? Oh, hell yeah, I got drilled in your brain. Good. G proteins, it's kind of what we just saw. You get a signal downstream, do something for me. And that do something can be very diverse. Other ones of these, well, yeah, the green one's another channel, just calcium in this case. Key that we want, though, is some sort of cellular reaction to the chemical signal. A chemical signal, a lot of the time, how I learned these complex systems was I always put an example there. Dopamine. Finding a dopamine receptor will trigger certain things to happen, right? Cortisol, the stress you felt when you forgot to turn in today's quiz. It went and bound a bunch of these. It caused a couple other things to happen. In fact, it even caused certain genes to be activated. Each of your cells. So, I wanted to note channels and how bad this is. Channels that allow the sodiums back and forth. If you blow up your chemistry, and you ruin the ability to go back and forth, not ideal. Easiest one from genetics was, remember cystic fibrosis, the lung disease, all in mucus? That channel does not work anymore. You got two bad copies. Instead of being able to go back and forth with chloride, nothing. Mucus accumulates, can't breathe. Blow up the channels, lose that language that the cells are trying to speak to each other, and we get this. Now, fun times. This is not pharmacology, but the two do play off each other pretty well. If a patient can't produce insulin, don't you have a bunch of cells waiting for the insulin to show up? Insulin's a signal, it has a receptor, it has an activation. What can we provide? This is an easy one. Just give them a good old shot of insulin, right? Bam, mimic the signal. Drugs are a little different. We sometimes want to stop these signals. Some of the key parts of stopping, for example, schizophrenia. You want to limit the amount of dopamine that's being shared. You want to stop that. It's too much. But again, this is not pharm. Can't strictly test you on the drugs. But the the way that I learned all the big list type of classes like these, big 400s, I made examples for myself where I could key on something specific, and that was my example. It helped me. You'll notice as we teach through stuff, I will often key on something. I want you to find your examples, but I will sort of guide you towards the ones that worked for me. Sometimes they'll work for you. That's kind of the key with the notes and stuff sometimes. All right. This one's focus is just what the word tissue means. Tissue's dense and nasty. It's like a big sticky matrix. Look at all these little guys, collagens, matrix, elastin, fibers. Look at all those little things. Epithelium is the broad word for the cells that are on top of your tissue. These line your intestines, these line everything. See those little cells? They're all functional. Wonderful. In this little membrane space right here, see these little guys? Those little fibroblasts are spitting out the little mesh, and they are keeping you connected. You don't want to just fall to pieces, right? But what would happen if these little guys got a little too aggressive and they grew too much? They sent too many growth signals out. What happens when too many cells grow? Yeah. That's why we'll see cancers pretty early coming up, is that technically they're in every system. We'll meet them every week at the end, usually. So, this is some good red text, don't worry. Here we go. Your cells, and the reason that lipids, the border is so perfect, is that lipids do not allow what to go past freely? Charges, right? They're nasty, they don't like charge, right? Those little lipids in there, you guys know all these. If you have a sodium ion, it's positive charge, chloride ion, negative. It is not freely allowed to go back and forth in the cell. This allows the cell, over time, as we've seen over the billions of years that we, as life, have been around, to decide when and who is allowed into the cell, at what times, things like that. So, you're probably familiar with most of this. Stuff that can go right through the cell. Oxygen, carbon dioxide, carbon monoxide, nitrogen, all the easy stuff, right? Small, uncharged. So the key thing that whenever I'm teaching phys too, you are not allowed in. You have a charge, or you are large. So, speaking of, glucose is one of the key nutrients of the body. It's too big to just be allowed in. It's too big. You can't fit through that. You need to facilitate this for glucose, for example. You need to make a channel or a transporter that is special to grab the glucose and put it back into the cell. No other way. Now, a way that you can trick things, though, are these little guys. Oh no, yellow on yellow, dang it. Most of your channels are this little guy right here, uniporters. They have one target, we go one direction. Most things want to be 50-50, but if you have something that only goes one direction, you can kind of cheat a little bit. It's kind of fun. How are these others cheating right here? Your goal is to get that red glucose in. Different ways to do it. You can make different exchanges in and out. You can use the other ions as a sort of currency. Find that the reason this is red text is just to remember chemical balance between here is a very careful game. And to ruin this balance, I think we're going to meet that first issue just a sec here. Oh yeah, we totally are. So let's talk about ruining this first balance right here. Yeah. Sodium, potassium. Look at all that. This got drilled into your head like a little hammer. Bam, right? Why? Why do you push all that sodium out of there? Where is this thing really cranking on all the ATP? From the whiteboard. There's a golden rule that I always show in phys. Cells that rely on that sodium potassium thing that we just talked about Your brain cells. The important ones. They're wide. If I told you right now to snap your fingers, go. Nice. It's quick, right? That reaction happened because you had certain neurons that told them to do that quickly. Reason that they were ready is this. Now again, we're doing basic phys in here. Anytime you want to know where the positive charge is on a cell, follow the sodium. Where is the sodium? It's the most frequent. You can, when you take phys, you'll see how potassium plays this role and all that stuff. Golden rule, easiest shortcut. Positive charge is where the sodium's at. Okay. Sorry, talked too much yesterday too. So the reason your cells do all this work to push out 99% of the sodium to stay outside the cell. Two things. You've got this wonderful sort of electric charge waiting on your cells to fire when you say. The way that it fires in most of your neurons is that when certain channels open, in red right here, when I told you to snap your fingers, your brain sent a signal that said open and use your muscles right there. That opening will allow a flood of all this 99% of sodium that was out there. It's all coming in as fast as possible. And that positive charge is that electric charge that you feel in your muscles and your brain. Same thing is going to happen in your central nervous system. So if I say 1, 2, 3, think of your best memory with your sibling. We all had something. Neurons communicating, facilitating that snap decision right there. So all your energy is, so much of your energy is spent on making sure that this is ready to go at any moment. I'm giving you the lowdown on action potentials, and we're doing it in 5 minutes. I love it. Okay. Here's what an action potential is. The biggest easy way to do this, okay? And again, I'm giving you this on a blue text. An action potential is simply that firing of sodium, that charge. Follow the sodium pulse. That action, that what we want something to happen. That something can be a lot of things. Like I said, CNS stuff, muscles acting, anything. The main one is that when you allow that sodium in, you say, activate, you release neurotransmitters. We'll meet all the neurotransmitters in this class. I love neuro, and I think some of you have taken actual neuro, so hopefully you'll enjoy that. But just to, I know it's blue text, but I always like introducing the characters when they first show up. If you fire, so right now as you guys are taking notes and learning things, glutamate is being fired by your brain. Glutamate is a short and then long-term memory facilitator. Same reason why people focus a little better when they're on nicotine in those first few moments. Next, GABA. GABA is a neurotransmitter that once it is fired, it runs around and it calms all the other ones, stops them. Make sure that they go down a little bit. The reason, for example, why people eventually get tired after drinking too much alcohol is that eventually too much GABA shows up. And they're tired. Yep, Ava.
Is that where gabapentin comes from?
No, and that's why it's such a bad name. Gabapentin's doing something in your peripheral nerves. It's stopping this reaction with a lot of the acetylcholine and muscle stuff, actually. I know. Sorry. I'll have to do that in farm, too. That's what I thought when I first did that, too. And I was like, why would they do this to us? So that's the reason we have hammered in again the sodium potassium pump. It's ready to go. That's why your brains work so fast. It's ready to shoot that out of there. And this is red text, but don't worry, it's okay. It's what we talked about. The neuron body is complicated, but these little legs right here, they're connected to other stuff. And every time they decide to activate one of the legs, they allow sodium in. That sodium positive is going to activate these channels and allow them in. And that flood will activate these channels. Allow that in. The potassium is there to slowly reset everything. Potassium is a less powerful force in terms of charge. That's why it's there. It's sort of it's us back. Pulse, the true electricity in your brain, your muscles, everything. Pulse is sodium. So, who's ever been to the dentist and they give you the shot? It's the painkiller, it's the lidocaine, right? All lidocaine does, this is why I like learning from examples, all lidocaine does, and the reason you don't feel any pain, it destroys these channels. Doesn't destroy them, but it stops them. So no sodium pulse, no pain, right? Can't communicate with the cells anymore. Say right here, lidocaine stops this. My favorite examples. Yeah. Perfect timing for a terrible story. I broke my nose playing hockey. We were in an emergency room in Denver, and I can say that I've had a nose job because the old scar was something like that. It was open and it was horrible. Nurse comes in, sticks the raw stuff with a bunch of lidocaine. I'm like, ow, ow, ow. Goes off for 45 minutes. The lidocaine disappears and they start stitching. And I'm like, ow, help, ow. And they're like, you're fine. And I was like, help. And eventually they had to do it again, but not ideal. I hate lidocaine. So, in a more strict fashion, you guys have probably seen this before. Your cells are always resting negative. Because remember, all the sodium is pushed to the outside. If you are allowed to trigger influx of sodium, okay, go up, but you do recover. The reason that you recover, we can actually all measure the amount of time that it takes our nerves to recover. Do a little contest here in a sec. But that pulse of sodium can only go and reset so quickly, right? So, everybody got to stop watching their phone? I love this contest because I'm competitive and I want to win, and I still think I'm good at video games because of it. Get out your clock and your timer and your stopwatch. How fast can you hit that stop-start? Twice. That is the limit. That is how fast your action potential can go. And no cheating where you do 2 fingers at a time and like hit it twice. 1. I'm going to beat everybody. You still got it. Come on. So try and get it as fast as you can on the app.
Oh, do you twice?
Yeah, so hit it twice. So like be like bam, bam. Or 1, for example. As fast as you can. You don't have to do thumb if you don't want.
I've done the same thing.
Oh, 0.8. Who's beating 0.8? Yeah, still got it.
We're supposed to be building harmony here, you know?
What?
We're supposed to be building harmony here.
No, competitive. Hey, there's a reason I have a useless talent. It's called Super Smash Brothers on the N64. Too fast, man. All right, what do we got? What numbers do we got out there?
13.
Yeah, that's good. I like this. Like 13, okay.
0.08 like 10 times in a row.
Oh, that's fast. Good. Didn't recognize your game sound.
Ooh, 0.07.
Bam. No. It's like a Thanos meet. Give me that phone. Is that an iPhone? Oh, it doesn't count. It doesn't count. What are we doing here? What are we doing? All right. So let's take one last example here before we have a little like kind of just discussion, quick time, and kind of a relaxed time. So we started this with cellular injury, and as you age, you accumulate cellular injuries primarily in mitochondria, right? Mitochondria do energy. Why do we need to maintain energy? Pump all that sodium out, right? If your mitochondria and your neurons start to slow down, is this system as quick anymore? No. So every time that you can, one of the best ways to kind of study this class, these big phys type disease classes, is always try and go back to the beginning and say, how did that factor in here? Even the basic building block parts. So I know it always helped me. Now, again, you don't have to do much right now. It'll take about 4 minutes or so. I'm sorry, 4 minutes might be a long time. But in this case, take about 1 to 2 minutes. In your notes, you can even put like, what are your impressions of cancers, tumors? Comes to mind.
I have a quick question.
Sure.
So GABA allows Cl to enter the cell.
Mhm.
And
And surrounding cells, yeah.
the surrounding cell.
Yep.
While glutamate depolarizes.
Excites them. So see how it's a positive, glutamate will inspire positive charges around, and that positive pulse in, that's a good activation, right? GABA allowing in chloride, sorry, is gonna negative charge. Stop that positive influx. Calm them, settle them down. You don't let them react. So back to the alcohol and overdoing the GABA example, you see people start to not be able to move quick, right? They're like, ugh, because there's too much, their charge is wrong. Hey, it's a common example. You're gonna see it in healthcare. We're gonna use this. Yeah, go ahead and this is like, we can take a little reset here, but yeah, just kind of think to yourself your major impressions, things like that. And again, if you have questions, now's a good always time. I can run on over. What you guys got for me on this? Start it off. Shout out anything. I'll add it. But yeah, I'm gonna say like this is a big one, and that actually is gonna help us out here because that'll be the link that when we jump from tumors to genetic diseases, there are some gene alleles that predispose you to having these deregulations. We're about to sort of intro. What else you got for me? And I know some of you know more than this. Think about our hallmarks from the past. Ah, sorry, it's in my palm. There we go. I can't start with the hardest one. Duh. Whoa, I
Yeah,
need
I
to.
was giving a mouse pad that one.
Okay, so in essence, which we will meet at the finale today, the aging of cells. How does a tumor actually kill someone? Spread, perfect. Yep. I'll put metastasize as invade or invasion. There we go. Forgetting the easiest one. Yeah, there you go. Too much mitosis, very bad, not ideal. Last one, I'm giving it over here. Sadly, it's all the way over here, but tumors have different powers. Every tissue predisposes you to different genesis. Pancreatic tumor is very different than a brain tumor. It's very different than a white blood cell tumor like the ones I study. What I'll tell you, you will get a growth, a tumor, something, if you have too much mitosis in a cell. 1 to 2 to 4 to all that's bad, okay? I'll tell you right now, you have a cell that will not die when it is supposed to from the signals that it's been given. Now you have a problem. Now a drug is not going to stop this. It's too hefty of an animal to kill. And how you will die is that these will eventually get to your brain, your lungs, or something else. And that's that. Can't win a war on multiple fronts typically. All right. Quick intro of what we're up against. Oh, go ahead. Yeah. Oh, you're fine. Yeah. Yeah, we did a little miniature hallmark time right here. Now, the good news is, in this case, you guys have done mitosis a billion times, haven't you? But like we've talked about in this class, when things go bad now. All the good things, in this case, there's an overabundance of good things in this case. All the phases right here are trouble. I'll be honest, right here, see that little highlight I just gave you? G0, where most of your cells should be right now. You don't want your cells to be dividing over barely. There are certain systems that you want that. The skin is always going. The intestine is always going. There are other systems that will meet, like the heart, that never do mitosis. That's why if you kill a part of the heart with a heart attack, it never comes back. But in terms of tumors, these checkpoints, they're there to protect you. Damage, cell that's too odd. If you don't pass one of these checkpoints in red right here, you should blow up. The apoptosis word. Cells are pretty set up that they detect something's wrong. Typically do blow up and they die. You have trillions of cells. It's much better to lose one that could have gone bad. And just like if you do have an injury of some kind, you do need to make more cells, right? So these are all good guys. If you have too many of these good guys, and in our case, we can just say mitosis promoters. We're not going to get into super detail here. But if you have too many factors that say go, 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 you're in big trouble. Yeah, my 3 cancer biology people are taking notes because we've already done this a little bit. Sorry, don't worry. You guys are having fun. All right. So the ways that that cells can be told to grow, for example, you get growth factors, like we all got bigger, right? We've all had wounds happen. And people always ask, well, like, what happens if you keep like, ouch, ouch, you keep getting cut or something in the forest? Is that going to cause cancer? Probably not. It's the wounds inside you that cause the cancers. You eat too many things that wound your intestine cells, or wound your endocrine cells, and they send the wrong signal. They're told to wound repair in the wrong spot, that's when we're bad. Okay. Reason we're introing tumors so quickly is that we will go system by system. And in every system except the heart, you will see tumors. There's only about 3 cases of heart cancer a year. It's because those cells, they're done. Once they start beating, don't make more. But in every other tissue, you run the risk of 1 or 2 cells going rogue and building itself a little faster than the others. But the word benign is that technically, you are still contained with this. Who's ever had a mole or a growth grow after a sunburn? It happens. It's okay. We all have to get them lasered off sometimes. Or sunscreen. But if you do get a little bit of UV damage, sometimes a couple cells go too fast after that. You mutated their DNA and now they're rogue. But under control. Benigns we can always surgical out or they'll just die off. But if you give a tumor too many genetic superpowers in the right environment, notice how it breaks free. Remember that matrix that I introduced before, that tissue, that mesh? Breaking free of that is the goal of a true tumor. And it is a violent, terrible, bad part of the tumor itself. This is typically where patients eventually come to the office and say, I have pain here. But at this stage, is it usually too late? Oftentimes, sadly, yes. Detection's getting better, but true breakaway and when tumor cell behaves more like an independent animal than it does a part of a whole, that's when you start getting in trouble. So, don't worry, we got a fun break slide coming up. We're almost there. I'm going to introduce you some, as I am as a cancer science person, which I am theoretically, or at least I'm paid to be. I do my best. First things first, you got go signals, you got stop signals in the cell cycle. Genetically, you must overbalance all the go signals. You got to make lots of these. The way you can do that, you got 4 of the 2 genes most of the time. Could accidentally copy one, and now you got 3 versions of that gene. That's too many go signals. Overbalance, bad dosage. That's fine, honestly. Oncogenes are way less harmful than you think. A lot of us right now probably have cells that have a few too many oncogenes, just there was a mistake in S phase and DNA replication, and stuff happens. But if you lose a gene, stop gene as I call it, at those checkpoints, now you're in trouble. You lose any of these 2 genes right here, call them tumor suppressors because they check the mitosis cycle. They say, you're not allowed to go through G2. You're not allowed to go through G1 or S phase. I'm protecting this. But if you mutate both, because you only got 2 copies, done. There's no more guards in the prison. All the go guys, they're going to run the show. Now, I'm going to go on a little green text here, so this is testable, but as you age, you simply run the gambles more times, right? You will have done mitosis more times, and eventually, cancer might show up just because of genetic time and genetic mutations over time, because that S phase right there, when you replicate DNA, mistakes happen. Plenty of cancers, about 15%, I would say, were just unlucky. So when we think of tumors, yes, you do need things that say grow more. Worst part is going to be losing your guards, basically, your stoppers. They are far worse. Here's the other best part. I got a big fancy drug. I can stop those offenders. I can drug them. Can I bring back a gene back from the dead? No. So to lose a stop is far worse. We're working on that, bringing them back from the dead, though. Not as possible as a year ago. Now, me, though, as a tumor genetics person, a bit of a tide is shifting. The tide is that most tumors have always been studied on the basis that they begin from mutations. Genetics do matter for tumors, but the environment around them is becoming more of a cause. So what you're looking at here is a couple exciting phenotypes that can cause different reactions. For example, some tumors, as we call hot right here, T cells kill tumors. The reason they're hot is that they are in the fight for their life against your immune system. Your immune system is built on these little T cell guys. They fight bad things. Plenty of your T cells are going to kill bad tumors. In fact, right now, all y'all have probably had over 1,000 times that a cell went bad and a T cell found it and killed it for you. May have had one even today, who knows? But the environment around the cells can change. Dysregulation of the immune system can lead to a type where there are no T cells present in a spot anymore. They can't make it there anymore. Maybe they lost a signal. Maybe they can't communicate with that region of the body anymore. And now there's no immune system to control all the bad guys. And it grows. A couple other environmental pieces. Certain cells that are not tumors. Sometimes your wound healing cells, like those little fibroblasts that make all the tissue for us, they get told by the tumor through the signals that we talked about in the beginning of class, make me a border, give me growth signals, feed me. There is a nasty set of signals that tumors can produce that say, I'm going to give you a positive signal, you will return me a positive signal. There's a nefarious thing right here. You have certain immune cells, T cells that are called regulators. They stop your immune system. What does the tumor do? Gives them a good signal. They show up. and they block your normal immune system. The tumor is facilitating this without genes. It's using the signals we talked about, tiny little ligands, paracrine signaling that we saw at the beginning. Didn't have to mutate much for this. The other signals that this can draw through, last little guys that I'll tell you. Two other signals that can be spit out. What hypoxia is saying that, or sorry, I should start with stroma. So what the tumor can sometimes do is say, I am a wound, I am constantly healing and scarring. What happens in a scar? It's thicker, right? That thick skin that shows up on a big scar. Tumors pretend that that's happening to them. They form a thick scar in the middle of your body tissue. And now oxygen can't get in. That's going to be good for the tumor and bad for the rest of the cells. Hypoxia means lack of oxygen. Tumors love that. We'll do O2 down. Okay. So the way that this happens is the environment can be accidental, that it thinks it needs to renew an injury over and over and over again. And when you typically renew injuries, you typically do mitosis. So take that. But the worst type of injury is the next red text line. Inflammation, what does that word mean to you? Sickness, immune cells, burning stuff. Yeah, it's a natural part. You need to burn stuff out if you have a pathogen. The problem is, what other things cause inflammation? We're not sick all the time. What are things that we eat or ingest or inhale that could cause this? Cigarette, vaping. It damages the inside slightly. Your immune system, when there's damage, it shows up, inflames the area because it thinks you're being killed by a pathogen, bacteria or viruses. So in this case, we're showing what injury inflammation is as we think of it. That little spike right there, you get a splinter, nasty. I didn't put splinter on the pathodex, maybe I should have. Splinter. But when you smoke, for example, you damage all that lung, and all the stuff shows up to repair it over and over, day in and day out. And eventually you facilitate the environment where tumor's going to pop through. And so these last two slides were a little more of a recent addition, because everything that we've kind of seen in the last 21st century has been a lot of the stuff that we've seen has been chronic overinflammation and constant damage response, causing a lot of the issues that we see today. We see more autoimmune diseases where the immune system is killing you accidentally than we ever have in the last 50 years. Our bodies are seeing things that make them mad. It causes them to spit out oxidants, things like that, inflame. Something's going on with the colon cancer rates where it's getting way too high. 40-year-olds, 35-year-olds are getting colon cancer, and not ideal. Maybe it's the plastics, maybe it's something else. I'm not 100% sure yet. I just know that I don't smoke. And then the most vicious of cycles of inflammation. Here we go. It's the beginning of an odd, this could be green text, I'd say, but it does give us a good signal system, okay? There's a good book called Why Zebras Don't Get Ulcers. Zebras are mammals like us. They have an adrenaline system that when you run, okay? We don't run from things anymore. But when you guys got worried about the quiz right there, or you're worried about the exam in 5 weeks, it's the same system hitting. We evolved to run from things. Guess where you don't need to put energy if you are running for your life? Do you really care if you're going to get sick in the next 5 minutes? No, you shut all that down. You shut those down, and you give way to the dumber of your immune cells, you begin to have chronic inflammation in the wrong spots, including the brain. Again, some green and blue here. And I wish there was a simple answer, but us having cognition and consciousness came with a bit of a price. We still have a physiological system that makes it harmful to be stressed. Yet here we are. Huh, shoot. Most animals cannot think of the future. We can. We can strategize. But in that strategy causes a lot of anxieties. We know it. Because technically, and this is a messed up thing to say to humans, the future is not a real thing, is it? It's not a real thing. It doesn't exist yet at all. We cannot measure it in any way, strictly. But dang, do we think about it? Not ideal. Because when you're stressed, you don't sleep. And when you don't sleep, your brain inflames. And if your brain inflames, everything goes down. What time is it? Why are we all stressed all the time and stuff? Why are we all upset? Anxious generation, the boomer. What makes the boomers not anxious? I don't know. We're gonna find out what they're taking. Anyway, speaking of other fun things, we do have a break lined up. Brother, I should put Ranger on that. Be bad. As you can see, my Photoshop skills have not lost their time. Unintentional injury. This doesn't mean somebody else didn't intend this to happen to you. Oh, wait, there's examples. Dang it. Don't look at that. Shoot. Dang it. Well, what can we add to that list? Oh, I know what. Does that count as fall?
I thought mountain.
No, Beth's got a point in like activity injuries. That's not bad. Hey, pulling a shoulder out doing sports. I would count that up here. Sports injury, sports med. There you go. What's that? Stabbing. Yeah, that's fair. She's right. Yeah, you guys are missing another big one on here. Why is the US all the way down there? What happens in the US? Yeah, you shoot people, okay? Guns, lots of guns. We've seen the Matrix. Yeah, well. So, S happens, right? This is pathophys. We have to know the conditions of what happens. You may laugh at a couple of these, but a lot of them are common. Yeah.
Do you happen to know what's going on in Finland?
I don't know.
I've never.
Wolf attack. I don't know.
That's why I said cliffs. Finland, isn't it on that peninsula? That has,
Or I've lived.
isn't it kind of, or is that Norway? Am I thinking?
No, hey,
Norway?
cold's not temperature injury. Yeah, you said cold. That's good. Yeah, where? Temp. There you go.
The same places. Yeah. Why?
Hey, yeah.
Finland's right next to each other too.
All right, anyway, forget about Finland. Okay. Blue text so you can go through the rich info on your own time. But yeah, all right, here's our first time. Blood and death, here it comes, all right? Yeah, stuff is bad. Blunt force. If you ruin the tissue, that's not ideal. You expose it, you do all kinds of bad stuff, you may never fix it again. There's a lot of different, and notice here what this is giving. There's a lot of different blunt force types. You don't have to rip open a foot as this poor person has done. Sorry. Anyway, what's a common injury? We talked about sports. A contusion. What's a common contusion injury in sports? Concussion. There you go. Big one. So remember, apply these things, the examples you know. Contusion right there is just in text. But when you put on right here on your own step, concussion, things start to come alive a little bit more. Text starts to be a story. Speaking of stories, I played football back in the day. You guys got any concussion questions for me? Back in the day of football, we were told, like, hit him with your head, Billy. Right here. Not ideal. Do not recommend. Okay, take a look over here. These are more lacerations. Slice, dice, and open. Versus a stab versus a cut are actually going to be two different things. A puncture versus a slice. Not ideal. Y'all are going to do some healthcare stuff. You're going to see some injuries. We're going to see some people doing some stuff to each other, okay? How to treat and what's going to happen. Okay. Oh, wait, there we go. And the big one. We will see there's some slides below. We're going to talk about the physics of these injuries. And again, this is a very foreign injury to the mammal body. There is no reaction to this. What happens to the bullet in most cases in the body? Does it stay whole every time? No. Remember all those micro injuries we just talked about with smoking? When you get shot, you got a long road ahead of you. That region is never going to be the same. In the movies, they get shot all the time, but man, it's not an ideal situation. Okay, I've never been shot, but yeah. Here we go. Let's break some bones here, right? One of my goals in this class, and like I know a couple of us are pre-dental in here, I think. And again, we're looking at the leg here. Man, the original bone break and the systems that the cells you have in your bones, they got minds of their own. It's amazing. The injury process that you go through with a bone break is awesome. Hematoma, more Latin. Hema, blood. Toma, growth. Gotta heal that thing. You gotta inflame that thing and wound heal that big time. After that, move in. Some great cartilage formers. They're gonna begin to reform. What's the first thing? Cartilage is the precursor to bone. You got that bit on your ear still? As you age, eventually it gets a little harder and all that, but to reform the bone, you first have to sort of lay some webbing. That webbing is going to allow, right there, blood highway and circulatory system will deliver you the oxygen to grow new cells, the nutrients and the growth factors will serve as a highway as well. That area right there is extremely sensitive now. Pathogens, bacteria. You do want your immune cells there. Once they are facilitated, begin the third and final kind of intermediate stage. Your osteoblasts will begin forming spongy, smaller version of the bone, and around that sponge will eventually form again. You will begin with still fractured bone after a break, but over time, fractures will technically heal back. This is the quote unquote stronger. You will build more bone back than you began with. It's not worth breaking it though. All right, who's got any good bone breaking stories, huh? We got Beth.
I fell off a horse and broke both my arms.
Did it intend? Did it kick you off?
No.
Oh.
But
Sorry.
my arm was like a caved-in bridge.
I wanted to see if
Had
she like was rude to the
displacement
horse.
there.
Yeah. Hey, Bob.
What one?
Hey, yeah.
Go ahead.
You can go ahead. Yeah.
All right. I was just gonna say that my brother made a really stupid choice when he broke he broke a bone because he did something really stupid as a kid. So we had a hill in our backyard. So he decided to go on. So this was right before family vacation too.
Yeah. What
So
did
he
you do?
decided to go on top of a sled and try to snowboard.
Oh
And
yeah,
he
we all tried.
completely broke his foot right before vacation.
That sucks. I'm sorry. We've all tried it. Lily, what do you got for us?
I got kicked at a dance competition in the 8th grade, and now my pinky doesn't straight.
Did you get Tanya Harding?
Yes!
What?
No, I'm not. But I love that movie.
Hey, it was.
Turn around and kill.
Guess what? It was real.
Been there.
Regardless, most of us, I think, have had something happen. I got away for a long time, and then it started in high school when I started playing hockey. It was like too many, bad. So here's some other good stuff: sprains and strains and tears and tendons and ligaments, right? ACLs, MCLs, all this good stuff. They are allowed in this. I don't know if they're strictly in the. I think I put ACL tear in the Pathodex. I might have. But it is blue. But yeah, this is different than breaking a muscle, obviously. Or sorry, this is different than breaking a bone, obviously. But the strains and sprains, they might feel like, they're fine. Technically, if you strain or sprain it, you don't tear it. It may try to regrow in the wrong spot. So like Achilles and like Achilleitis and stuff, like where people get older and it's like can't move as much. It's because they stretched this and inflamed this and strained it, and it kind of grew more on the bone than it was supposed to. Sometimes that can happen, yeah. Now, obviously, you can tear these things too. It's not ideal. And I put foots up there. But yeah, if you're a sports person, knees, patellar tendons, all that good stuff, it can all go down. All right, I promised you some details. I put this in at the end because I was like, well, it's a unique injury. None like it in the planet. Nothing, no pathogen or conditions like it, what it does. That's why you took all those physics, by the way. Let's take a look. There are different, you don't need to know each type. What I want you to know is that there are different ways the bullet will spread. But look at the unique features here. Every bullet comes out. Man, some bullets, like a hollow point, it's not good. There's a reason why certain bullets are illegal. It's not on here, and I'm not trying to go like full video game or anything here, but there's certain bullets that are illegal outside of the military because the cavity that they make will basically explode a person. It's pretty rough. Some of the stuff that you don't know, that you don't like really think about is like, you see the movies of people get shot in kind of stomach area or like any of these other spots. No, dude, it's not happening. That adrenaline will keep you going for a bit, but those cavities are big right there. And like we talked about, gunshot victims, it can be a long road. Your body does not know what is inflaming it. What are these particles in me? Why is there a permanent cavity? Was something supposed to be here? The wrong cells go to the wrong spot, all kinds of stuff. There are options where, stuff completely regenerates, that's fine. But your body doesn't strictly know how to handle this injury. It's a modern injury. What our body knows how to handle, what did we evolve against when we were running away from things? What do our typical enemy species have? Teeth, puncture wounds, we're good at healing.
Obviously on a smaller scale, but like, what is the difference with piercings versus gunshots? Like, you permanently just have something in that hole.
The force of the gunshot will blow out this, and that's because the physics and Newtonians will, it'll force the molecules around it to essentially rip apart from energy and explode out. The mass can't go anywhere else, so it typically just dies in that region. Everything necrosis dies. Now, and the other thing, and I know part of what we skipped up there, so I mentioned, and this was our first time talking about, but your cells do apoptosis, where they blow up if they're bad, right? If you kill your cell in a bad way, it's called necrosis, like necro death. That's happening in here. I'm gonna go ahead and pop a little guy in here. Necrosis means that those cells are spilling all their nasty chemicals and guts, and they are unregulated and bad. There is nothing to tell what's going to happen to that injury when you blow those cells up. So we saw the cells in cell injury, but if you leak all that stuff out in the natural world, in your body doesn't like those things. Apoptosis is organized, chews everything up, puts it into packages, and it's nice. But if you blow stuff up and necrosis happens, you're deep stuff. So speaking of next conditions, why on the bottom right there? And you can survive a gunshot to the head because it ricochets quite a bit of the time. More than you'd think. Why is getting shot in the stomach so damn bad?
The stomach contents.
Yep. Acid, bacteria, everything. It's going everywhere. And you're going to die pretty badly and for a long time. Yeah. So that's why in Reservoir Dogs, when he gets shot, he wouldn't have lasted that long. So kind of the same red text here, but again, just to emphasize that this is a condition, whatever you want to call it, an injury that is unique among all the others we see throughout class. The angles at which you're shot, everything. It all matters for how much this cavity is going to build. The bigger that cavity, the more permanent damage you probably have. Any tissues that you get in these shock waves, they will be affected in some way. Talked about just any deregulation with these cells. If you move them around, they don't like it. All that tissue matrix that we just saw, some of this that will never come back. So, and again, kind of like Tony Stark, where he's got the shrapnel moving around in him. Same idea. If you got shrapnel or bullet stuff in you and you can't find it, hopefully your body surrounds it with scar and it stays put. That's the best case scenario. Usually. All right. So I shouldn't have maybe skipped homeostasis, but the word homeostasis means your body wants to stay normal right now, right? What's not happening normal-wise in this case? What's happening to these poor patients right here? Too cold? Way too hot? Bad. Talked about our endocrine system, the hormones, anything like that. If you damage those cells for any reason, disease or otherwise, you may lose thermoregulation. But what's our best thermoregulator when we get warm, though? Big old fever. Or again, obviously you can do heat stroke, all that stuff too. But if you mess all this up, body systems don't like that. They'll try to stop it if they're not being told to do it by themselves for a fever case. If they can't stop it, a lot of cells are going to die over time. Or a lot of things will slow down. This is also the cool part with this whole setup. Who's ever been, oh wait, it's so cold outside right now. I got to walk home today too. And I'm the idiot who likes the cold. I deserve this. Hypothermia is a good example to start from here. True systemic deregulation. Everything is having trouble here. Why do people that get lost and get hypothermia, why are they confused? What's not working that we learned here today? What is not fast anymore? Literally, the chemicals cannot move when they're not hot, right? Why do you warm up before sports? You really are actually getting things moving so that you are faster. That's part of it. But I like starting with these big systemic things so that as we keep going through class, you'll remember this part. See this idea pop up as we go through each system, and you'll be like, these big conditions, they had a meaning everywhere in all these spots. So don't get lost on the mountain. That hike ain't worth it, probably. My favorite. High altitude encephalitis. HACE, whatever you want to call it. Who's ever been? What's the highest altitude anybody's ever been? I'm competitive from Colorado. I grew up at like 5,000. What do you got for me? Ava?
Mont Blanc in Switzerland.
Oh, that's actually sick, really? Awesome. Shit, I'm jealous. All right. That's pretty badass. I will say that the time that I was in Peru and we did some high altitude stuff, I was all like, I'm pretty confident in myself. Yeah, I got put to work on that mountain. We were up at like something way up there, and I was just like, I think I've lost my stuff. You can acclimate to this, and you can be born with certain genes that help you with this. The Tibetan people still have a Denisovan gene from that region. One that allows them to facilitate this. Now, in a chronic phase, though, the disease itself is going to affect one big organ the most, and that's your brain. That's why I highlighted, this is where Yetis come from. This is where hallucinations on the mountains come from, where you think you see something and you don't really. I'll even admit, and again, Green Tech story time, I went on a little vision quest, quarter of a life crisis, whatever you want to call it, to Colorado, hiked some mountains, because I never hiked 14er and I was jealous. So, did have a moderate 2 hallucinations one time. One time I was like, gold. I literally thought I saw gold on the ground. Yeah, a little rough. And then the other time was I thought I saw lynx. I was like, the lynx. And it wasn't there. I was like, oh, I'm so tired and old. But I said, not yet. We made it to the top. Don't worry. Okay. So, big systemic, big stuff. That's what we're dealing with here. One of the other slept on systemic things is good old radiation. Come from a lot of different stuff. I'm not saying don't get on a plane, but radiologists do significantly get exposed to more stuff. Older buildings have radioactive material in them. If you get radiation, what it's going to do is fry up the oxygens in your cells. Those will turn into chemicals that grab and covalently bond things wherever they want, and it's bad. Yep.
Is this blue or is it red?
It's blue. Because we didn't have a strict like radiation poisoning part because it is really rare. You guys seen Chernobyl? They decomposed from the inside. They got so much radiation.
Radiation from tobacco.
It's what it's made of. Smoke, the cigs. Yeah, they have, no, it's okay, yeah. They're made of stuff that's got radiation in it, and then it goes right in you, and then emanates. Don't smoke it, guys, okay? Please. All right. Now, yeah, there's a lot of stuff, but it's all stuff you guys kind of remember. It's aesthetics. Cofactors. These are what you would also call micronutrients. There's all your pills and your vitamin B's, your vitamin A's, all the stuff in a Celsius you could ever want, right? Stop drinking those. Now, if you lose those things, if you lose any of these little guys, that's why I like this slide. I know it's red. There's a couple Pathodex things on there that's like vitamin E deficiency, vitamin D deficiency. What happens? What systems are going to go down if vitamin D is not around? Your lipolysis goes down, liver's not doing as well either. And if your liver's not doing as well, you're not detoxing as well. You're not detoxing as well, all the cells are getting that bag, but it's nasty. Okay. So cool, I mean, got a good idea right here, for example, highlight one of these. Let's go with, where's my vitamin C? There it is. No vitamin C. Scurvy, pirates, yar. Had no vitamin C, no fresh fruit. No vitamin C, start to degrade those skin cells. They start to lose some of their minerals. Your immune cells start to inflame and die. That's why you see that nasty like growth all over it. Uh-oh, we are on the last 5 minutes of my PC. Let's do this. All right. If you accumulate too much of anything in the body, the cells will absorb it naturally through concentrations. And I mean dust, I mean sawdust, I mean fucking anything, smoke, anything. Don't breathe in too much anything, okay? You kill off all this stuff. Or if you mutate, or if you have an abnormal metabolism because of what you eat or breathe or anything, these cells will not behave the same way. You'll screw up what you're using as food. You will accumulate bad proteins if you stop transporting them properly or recycling them. There are a lot of things. Number 4, indigestible particle. What does that sound like? It's very niche now. Plastic time. Yeah, shoot. I don't think we're going to solve that anytime soon. So if you get those bad injuries in there with these little accumulations of any weird thing, cells won't behave the same way. Different deregulations will happen here. Lead poisoning, things like that. Any poisoning you think of, start here. So, talked a little bit about necrosis. If you kill your cells, cold, heat, shock, anything, they'll blow up and all the materials are out for everybody. And they're going to cause all kinds of inflammation and death, okay? Real nasty, not ideal, very bad. The last one, we made it. Last thing that can happen to you. Senescence. There is a choice that your cells make, one last choice. Instead of dying, I'm going to go what's called senescent. I'm going to go into a state of non-growth and stasis. I will stop working. I will stop functioning properly, but I will sort of maintain myself. Now you're talking gray hairs. Now you're talking neurons. Now you're talking, as you slowly lose function, your brain isn't dying of neurons. They're simply slowing down. The problem is if you get too many in a group that slow down, that tissue will begin to age as we see it and deregulate as we see it. So, all right. You guys good? Yay! Just kidding. Dang it. All right, don't worry, it's not great. But every 400 level class has a pretest, as you'll see here. Ava and Zach, you guys are good because you already took this in farm. But yeah, I gave you guys the wrong test. The first 10 questions are right, though. So how this works is I got to shut my computer off so that we maintain the recording.